transversals. And when you have two lines that intersect, you get something called vertically opposite angles. So here we have angle 1 and angle 3 being equivalent, and the measure of angle 4 and angle 2 are also equivalent. We also have something called transversals, and it's a line that intersects a system of lines. Here's an example. You have a pair of parallel lines, and the blue line is the transversal. And when this happens, you end up with 8 different angles. These angles are special because we have names for them. If you look at this first example, here's your set of parallel lines in the transversal. The parallel lines, think of them like railroad tracks. And inside the railroad tracks, we have some angles. If you look at the red angles, you have one on the left side of the transversal and one on the right side of the transversal. And the red angles are equal. So for example, if this top red angle is, say, 30 degrees, the bottom red angle would also be 30 degrees. The same is true with the green. Notice the green on the right side of the transversal and the green on the left side of the transversal. Again, they're inside the parallel lines. That's why they're called interior. So if this green one is, let's say, 150 degrees, this green one would also be 150 degrees. Alternate exterior angles are angles outside the parallel lines or outside the railroad tracks. So if you look at this red one on the left side of the transversal and the red one on the right side of the transversal, they'd be equivalent. So again, if the top one's 150 degrees, the bottom one would be 150 degrees. Same for the green. The green here on the left side and the green on the right side. So if the top green is 30 degrees, the bottom green would also be 30 degrees. And then the last one are the corresponding angles. And there we have 4 sets, so I use 4 different colors. And they are ones that are on the same side of the transversal. So if you look at this transversal and you look at the purple angle, let's say that's 150 degrees, that means this one's also 150 degrees. It's on top of the first parallel line and on top of the second parallel line. The red one's on the bottom of the top parallel line and the bottom of the bottom parallel line. And again, those two would be equal. Then if we look on the right side of the transversal, the top of the parallel line in green, the top of the second parallel line in green, and the bottom of the first parallel line in blue, and the bottom in blue. So let's look at some vertically opposite angles. So here's an example of a set of parallel lines with a transversal, and we have 8 different angles. So vertically opposite angles would be angle 7 and angle 6. Also angle 5 and 8, angle 3 and 2, and angle 1 and 4. Now let's look at our different types of interior, exterior, and corresponding angles. So let's look at an alternate interior angle. So if I look at 3 and 6, those would be alternate interior angles. Again, they're in the inside of the parallel lines on opposite sides of the transversal. We also have angle 4 and angle 5 inside the parallel lines but on opposite sides of the transversal. For the alternate exterior angles, they're outside the parallel lines on opposite sides of the transversal. So angle 1 is on the left side of the transversal and angle 8 is on the right side of the transversal. We have angle 2 and angle 7, again on the left side for angle 7, on the right side for angle 2, and outside the parallel lines. Then we have our corresponding angles. Angle 7 and angle 3, again, if you look at this one, they're both on the same side of the transversal and on top of the parallel line. Angle 5 and angle 1, again, below the first line, below the second line, on the same side of the transversal. Angle 8 and 4, again, now we're on the right side of the transversal, on top of the first line, on top of the second line, and angle 6 and 2, on the bottom of the first line, bottom of the second line. So let's see if we can figure out some measures now of these angles. So let's say the measure of angle 1 is 70. That M means the measure. So let's put 70 in. Now let's find the measure of some other angles. So let's look at angle 5. I know that angle 5 and angle 70 are equivalent. And they're equivalent because they're corresponding angles. They're on the same side of the transversal, but notice this one is below the first line and this one's below the second line. Now let's look at angle 4. I know that angle 4 and the 70 degrees are also equal because for this one, I notice that they're on opposite sides of the transversal, but they're both inside the parallel lines. So alternate interior angles are equal. Let's look at angle 8. Angle 8 and angle 7 also are equal. They're on the same side of the transversal and their corresponding angles. So corresponding angles are equal, just like on here with this one would be just like the green ones. Now let's look at angle 3. Angle 3 and angle 70 make a straight line, so that means that they're supplementary. They equal 180 degrees. So if I subtract 70 from 180 degrees, I'll get 110 degrees, so angle 3 is 110 degrees. Angle 7 and angle 10 are corresponding angles, so they would be equal. Angle 2 and angle 10 are on opposite sides of the transversal and they're outside the parallel lines. So angle 2 is equal to 110 degrees because it's an alternate exterior angle. And lastly, angle 6. Angle 6 is also the same as 110 degrees, and that is because it's corresponding. You can see here it's on the same side of the transversal, below the first line, below the second line. So here's another one. Let's see, we've got angle 1, 2, and 3 to figure out. Well, let's see, angle 1 and angle 10, I notice that those are opposite each other, or vertical angles, and vertically opposite angles are equal. So angle 1 must equal 110 degrees. Angle 2. Angle 2 and angle 110, I notice they're on the same side of the transversal, and they're corresponding angles. And corresponding angles are equal, so angle 2 is 110 degrees. And lastly, we have angle 3. Angle 3 and angle 110 make a straight line, which is 180 degrees. We say they're supplementary. So 110 degrees subtracted from 180 degrees will give us angle 3. So angle 3 is 70 degrees. Now let's look at this one. I notice that I have a set of parallel lines, and it looks like a transversal here and a transversal here. Let's extend them so we can see it a little bit better. So we have two different transversals going through one set of parallel lines. Let's see if we can figure out angle 1. Well, I know that angle 1 is equivalent to angle 63. Because angle 63 degrees, it looks like these two are vertical angles, and vertically opposite angles are equal. So angle 1 must equal 63 degrees. Now let's look at angle 2. Angle 2 and 63 degrees are also equal. And they're equal because alternate interior angles are equal. You can see here's your parallel lines and here's your transversal. So angle 2 is 63 degrees. Now let's look at angle 3. Angle 3 looks like it would be a straight line if I could add it to 70 degrees and 63 degrees. So these all together equal a straight line. And straight lines are 180 degrees. We call it a straight angle. So the sum of those three angles is 180 degrees. If I add my 63 and 70 degrees, I get 133 degrees. I subtract that from each side, and angle 3 then would equal 47 degrees. Lastly, I have angle 4. And I notice that angle 4 is on this inside of the parallel lines, and so is this angle. And they're on opposite sides of the transversal, which means that they would be alternate interior angles. So alternate interior angles are equal, and the sum of 63 and 70 is 133 degrees. So that means angle 4 must be 133 degrees. Wow, okay, here it looks like we have two sets of parallel lines. And I want to find a vertically opposite angle to angle 10. So there's angle 10. Well, vertically opposite is angle 12. I made the lines blue so you could see where they intersected. Now let's find two angles that are alternative interior angles to angle 13. So angle 13. So if I make these lines red, hopefully that helps you see that I'm looking at these parallel lines and this is my transversal. So the two alternate interior angles, we could use angle 5. And then if I highlight the other red lines to show those, also angle 11 works. Now let's find two corresponding angles to angle 1. So angle 1 So here's one set of parallel lines. So corresponding, you can see this is on the bottom of this line and on the bottom of this line, and this is your transversal on the same side of the transversal. Now let's make the other lines purple. And you can see again angle 1 here on the top of this line and angle 3 on the top of this line. Now we're going to find two interior angles. We want them on the same side of the transversal as angle 6. So angle 6, I'm going to highlight these, and you can see now that this right here, these are your two lines. Here's my transversal. So you can see that they're inside the parallel lines and they're on the left side of the transversal. Now angle 6 and angle 7, again, now I'm going to make these two lines my parallel lines. Here's my transversal, and you can see that they're on the right side of the transversal. Now we're going to find three angles supplementary to angle 8. So there's angle 8. So angle 1, that would make a straight angle or 180 degrees. Angle 7, again this way, 180 degrees. But also angle 5, because we know that angle 7 and angle 5 are equivalent because they're corresponding angles. Now let's find 5 angles congruent to angle 7. So here's angle 7. Angle 1 would be congruent because vertically angles are equal. Angle 9 would be equal because alternate interior angles are equal. Here's your transversal. Angle 3 would also be equivalent because alternate interior angles. Again, now we're looking at these two sets of parallel lines with this being my transversal. Angle 5 would also be equal because they're corresponding angles. Angle 11 would also be equal. Again, corresponding angles. We've just changed the transversal is here now. I hope that this helps you to understand a little bit more about transversals and interior, exterior, and corresponding angles, as well as vertically opposite angles. If you enjoyed this, that's great. I hope you did. And there are more problems that you can do. Just go look at some of my other videos and have fun. And thank you, as always, for watching.